Type of BHP analysis are we doing? Did I say we're doing? From what we have here. Eh? Is a build up. Good. Okay, it's still there. This is the gradient for the first one that I said is gas. This is the gradient for the second one I say is oil. And I said if you want to see their intercept, which is this point here, you have to click on this intersection. Intersection will give you the depth where gas and oil meet. So that intercept has a pressure. This is the pressure. What information? Intersection is actually this point, because if you put your cursor close to it, it will be giving you 30668. Can you see it? It's the point where the oil and I said that point is very important to a field engineer or a production engineer, because if he's going to lift his well, he knows where to put his what do they call it? The gas lift mandrel or injection point. As you clicked on this intersection, it showed you now the depth and showed you the pressure at that depth. Yes, that's what I said. For the well, not for the reservoir. For the well, not for the reservoir. In that well where gas and oil met is what is giving you. Okay. Okay, so let's go to our main work. Okay, so now we're going into the analysis proper. Now, in the analysis, we want to see formation and well parameters, especially your skin and permeability is key to us, is key to a production engineer. So to do that, we have to assign rates to all these rates. Sometimes the company will give you what the rate they flowed these wells. But if you're not giving the rate at those choke sizes, you have to like come in with your own rates and all that. But let's imagine that I'm going to give you, I think I wrote. Okay. I have rates. So pick the rates. I have 1003. I have 2003. Write it out. We'll use I have 2700. 132327. So because of time, I'm just going to give us the information on how I got them. All these informations are here. Do you understand? Now we're going to do the full interpretation. The first thing when you open your data is that everything that happened here before you got to your target depth. What is our target depth in this test now? Let me see who is following. 10,300. In Sapphire, we call that a pre-survey test. So it's not counted. So what we're going to do here is that come to when we want to do analysis. Check here, you see analysis 1. You see, or if you don't want to go through here, you can go through interpretation. Are you getting it? But I prefer to leave it as this QAQC and go to analysis 1. Can you see analysis 1? Good. So, but for us to go there, let's do edit rates. We need the rate data, because remember what Prince told you, that it was the rate that was perturbing the well that gave rise to the pressure informations that you have. Clear? So we need that rate. Okay, now to get that rate, if you click on edit rate, you see duration and the liquid rate. Both shorten and drop down, they are what? Rates. When you shorten, what is your rate? 0. Be bold to say, because I know he must have told you. And when you're flowing, you have a particular rate. So both of them are rates. So that means where we're doing this thing. So from our this thing here, how many drawdown do we have? I wanted us to write that those drawdown in this thing. We have the first drawdown, Abi 1, drawdown 1. Are we listening? Drawdown 2 and drawdown what? 3. And then build up. How many build up do you have? Build up 1, build up 2, and build up 3. So I want you to write it on paper first before we enter here. So we're going to do the calculation on paper. Go back to your, write like that for me. Draw down 1, draw down 2, draw down 3. Build up 1, build up 2, build up 3. That's what we use to fill that edit rate. So, but where to get information is in the wireline man's report. You go back to that report. When you go back to that report, see what he did. All the time he spent before he got to target depth. Is it possible for us to calculate it? You can calculate it either from here directly. It is from here. Let me enlarge this guy. I wanted to enlarge. I picked the wrong one. Sorry, I just wanted to show us something. He was flowing until he got his target depth. So everything from here till here is like washing your well, cleaning the well, purging the well for build up. Do you understand? So everything that happened before he got to target depth, we will call it pre-survey. So you can use your eye to put it. You can do like here. I can do, when you come to duration, I can put something like let me put 3 hours, and for that time we assign the rate as 0. Do you understand? Hour and then your rate, stock tank barrel per day. So if you do that, once you enter, are you seeing what it has done? It has shown me the period that is my pre-survey. But this period, I know that is not correct because I overestimated. Can you see? It has passed that place. I want it to be exactly at this point. So how do I get the exact time he used for his pre-survey? I can only get it from here. Hello?
Yes.
Remember that our elapsed time that we did not do anything with. From when he opened the well and tied the gauges to the lubricator, how many hours did he use? Please, can we look at it? See, when he got to that, how many hours did he use? He started from here, 0.238 something. Can somebody add it for me? Elapsed time. Down to, he ran a whole till he got to, where is the target depth? Here. So the entire time he spent was to get to that red point where I am now is what? 2.86. So the correct timing is 2.8622 if you want to capture everything. So that is how long it took him to be running in hole till he got to that depth. So write 2 points. 86222. Oh, sorry. In place of the 3 hours I just put there was not correct. 2.8622. Abi?
Yes.
Good. So you can see that it will shift this guy to the right place. When I finish here, you're going to see it. So what did he call it? Pretest. Pretest what? And it's 0. The rate is 0. Sorry, I know that most of us will not be familiar with this. I just want to be sure I've overclicked. It's okay. I can see that it's okay. I come back. Okay? So after it, he flowed the well. That elapsed time, remember that elapsed time story, is going to help us to capture the time very well. After he got to maximum depth, he flowed the well for how long? Hello? What?
Time is 2.8622.
If you round it up now, it's 2. 2 will still give you nothing. Do you understand? So it's okay. So it's okay. So we want to capture how long he flowed the well at that point, at what do you call it? So for us, we were using the elapsed time where we got the 2.88 something. Look at, he moved it to that 3,000, what's it called? 10,300. Please check for me how long did he get it. So we're going to look at this point here. Are you seeing it? He left it until this point where you have 10.21722, is it not, where he did the choke change. That means the gauge was there until he started changing choke to another flow. Are you seeing it? Till he did the first shorting. So from this 10.21722, minus it from 2.862. Please do the minus for me, please. I didn't mean this thing was separated. We'll just pick it there. 10.217. Are you seeing the usefulness of the elapsed time? 22 minus, the other guy was 28, abi? 2 points. My eyes, oh. 28, abi? 2.86322. So that is, I don't know, my own is not correct, right? Somebody is saying 7 point. Okay, so that's what you will write there. That's the correct time for the next. So to be able to do that, you have to click on this guy and then add. Click on the one you've written on already, add, so that you add a new row. Is that clear? Have you added the new row? So what's our new time? 7 point what? 29. Three, 5. Good. And that is the, if you look at our this thing, that's the lowest rate. The choke was at choke what? 20. Do we remember? The choke was at choke 20. So pick it, pick that rate. The smallest rate there is what? Give me the rate. 1,000 what?
300.
300. So you add again. So that was our drawdown. Our drawdown 1, abi? So we add. So the next thing we're going to bring in that sequence is our build up 1. True or false?
Yes, ma'am.
You're going to bring in your build up 1. What have I done? Hey, I'm going to click that nonsense guy. Okay. Your build up 1 will be what? Please look at the build up 1 now. Build up 1, when did he now start changing the choke to the next one, or for flow? So I'm having 12.36 now minus 10.217. Check it. Okay. See, this guy flowed this well for this 7 point something hour, 7.3 something hours. We want to capture the time, the duration. The target point is shorting now, and later he opened the well. Okay, so I'm just capturing this shorting period and the time of flow. The time he shorting and the time he was changing before he did the final build up. So we have captured this one now. Let me go back to, we have captured this pre-survey time. We have captured the first flow. The first flow took about 7.355. So we want to capture the build-up time. That time he was changing the choke from 20 to what? 24. That's the time we want to capture. And I said, if you look at the elapsed time, it took him from 12.36. Abi? We'll minus it from the other time, which is 10. Minus it and let me see what it is.
12.36.
Equals to 12 points. You should be getting 2.15 thereabout. Yeah, I don't need. So go 2.15. And what's the next this thing? That's our next rate. What's the next rate at 24? 2.3. Okay. I don't know. Okay, sorry, 0. Nobody was even talking to me. When you're building up, how can you have rates? He shot him to be able to change that choke. He's now bringing the rates. Please, don't confuse me. So let's look at the next elapsed time. What will be the next elapsed time? Calculate that one by yourself. The next flowing time. Somebody calculate that one and let me know. But if you get it correct, you should be having 9.5033. I don't want people to keep me here. Check. To the next. This is flow now. We did 12 point this. So the next one was what? He changed choke. Abi? So do this 19, is it 19.26 something? No. It should be 21. At that point, he opened the well to flow. Check.
9.50334.
9.50, yeah, you're right. You're right. 9.5033.
And you're playing at 2000.
I like your this thing, your speed. 334. What was his flow now? 2-3.
2300.
So we add again because after he flowed for that 9.5 hours, he now changed the choke to the final drawdown. Abi, when he was changing the choke, he was changing from 24 to what? 28. So check for me. If you get it right, you should be having 0.32. Check.
What did that do?
You say? I should show you.
Yeah.
You have the Excel now. I want to be fast. I want to ski on this thing very fast. After he has flowed, he shot in the well from this point to this point. So minus it for me. What do you have? 0.3216. Correct. 3216. The rate is assigned though. You were not there in the field. The field man gave you the rate, that this is the rate my well was flowing.
Zero.
So at this point, he was changing choke. So it's 0. So the next one we add is going to be what? The final build up. How many hours did he build up? Go back to your sheet. No, the flow, the last flow, please. Jordan 3, please. Jordan 3 had the highest rate. So what do you have? Minus it for me now. He changed to 28 before he now did the final build up. What did you have? 30.6 minus what? If you calculate, you should be having 8.4, 8.4617, 8.446 abi 70. Please check your own too. So 2,700 is his final drawdown. We are using the elapsed time, oh. We are using the elapsed time, please. This elapsed time. The first thing on our gauge was what? Date, time of the day. Then we had elapsed time before pressure. Do you remember? I said elapsed time only helps you to calculate how long it took you from one step to the other. Are you getting it? So difference, yes, that's what we're minusing. We just minus this one now. 30.65, good. And we got that 8. So now let's do the final one. I told you the rate is given to you by the field man. It's not, we didn't get it from anywhere here. It's not given here. It's just like I have finished flowing my well and I told you that this well I flowed it at 2,300 suck-time barrel. Okay, so it's not, you didn't manufacture it. So let's go to the build-up, the final build-up. How do you get the final build-up now? Okay, so what's the time? If you take from 47.4438, but if you get it well, You should having 16.79. Okay, you're subtracting the latest will I say event from the subsequent one using the elapsed time. Like this one now we use 47. It was around 47 point this thing before he started pulling out of O. If you minus 47 point this thing from 30, check 30 point this thing, it should be giving you around 16.79. Look at it. 47.48 minus 30.65. That is when he shot in the well till when he decided to pull out of O. What is this time range? Get it. It will give you, somebody give me that, this thing should give you 16.79. If you don't want to do this, you can use your eye to get it. This one, we're following his information. You can as well, we will open it, you see that even his information is not correct. Absolutely correct. When I zoom in now. So this is what? 0. So we're done. Good. Are you seeing what we have? What we want to do is to assign rates to all the pressure information we have here. I said the first one is the pre-survey, and the pre-survey is all those flow you did before you got to your target depth. Correct?
Yes.
And when we go to the target depth, we flow the well for a particular time. So now I'm going to zoom in to see if this thing is correct. If I open here up, are you seeing it? This is exactly like where he got to before he started flowing the well. I'll go back to reset. I now view this other part to see if he got it exactly. I can also use this my zoom reset to check. It's okay, it's correct. But you see some that are still not okay. Use your zoom reset and be checking it. He now flowed the well again. Let me use this one. It's okay. You check all of them. I go back. I check this one.
Correct.
Good. The timing here, it seems okay. I go back again. I need to check all of them, especially there's one I will not check so that I can teach you something. There's one I will purposely not check. Do you understand? This final build up, I don't want to check it.
It's wrong. So this one, the first one is correct, but the last one is wrong.
Okay.
The
So
last
let me go back. I'll check the last, this one, Abi.
Not this one, the last one.
Don't worry about that one.
The last one.
Don't worry about him. What we said is the time the guy used to do this test. According to what was recorded to us, he used how many hours? He used 16.7 hours to build up. So it's exactly where we stop. So this other stops, no concern us. Do you understand?
Yes.
It's okay. So we have interpreted our rate for all the pressure. And you can see how stepwise this last drawdown gave us high rates, followed by this, is it not?
Yes, ma'am.
So if I ask you to design a test, you will know that for higher this in drawdown, it will follow with a high rate. So we're done. Once you're here, your work is half done. Is everybody here with me?
Yes, ma'am.
Eh? You move it. So good. I love you. Come closer for saying that. Even if I'm hurrying and you captured me in a place that is very important. Now, I'm going to move some now. Please, but you will help me to put it back. Let's say you open this one now. What did I do? I've moved it, Abi. You open this one and let me reset. Let me see where it come. No, it didn't. I've moved it from where it is. It's not more correct. So for me to move it, I have two icons here that help me to move it. That's why I say God bless it, because it's very important. I'm going to use this one that has a cross, this red sign that has a cross. Are you seeing it? I'll pick it. I'll come back and say, no, you don't jump. Now here is supposed there. Are you seeing it's moving with me? I move it. It might not really be correct. I will have to come back here and reset this thing. So there is something that is missing here. This one now is giving me 10. It's not supposed to be 10. How many hours did we flow test? 2.86. But you can move it. Are you seeing it is back? So something is missing. This two is missing. So this one is what? The first flow. 7.355. So if I don't want to use this to move it, I can see that something is still missing. I can use here, I can zoom. I over zoomed the last time. That was what happened to me. Are you seeing? So I come here, I use this guy, this plus sign, and I move this man. I say, no, you're meant to be here. Did you see it?
Yes, ma'am.
So I can move with this, or I can also move with this other one. This one helps you to move one point at a time. You see? It will not jump point, it will be moving one point at a time. Are you seeing? The only one that can help you move it smoothly like that is this one. You can move to where you want to stop. But even at that, this thing is not correct. You keep zooming until you can move it to the point you want to move it. So I don't have all that time. Let's come here and reset it. What is it supposed to be?
2.15.
Is there anyone not correct in my own?
Yes, the next one is
Eh?
9.503.
9 points.
503.
Okay, which other one? It's correct, Nabi. Check for me. It's okay. I click. If you click, you should be here. Are you here? Analysis. Click on analysis. Have you clicked on analysis?
Yes, ma'am.
It's analysis 1 that will show by default. So the next thing you have there is your extract dp. dp is your derivative. You want to get the derivative, and it's the derivative that will help you to do interpretation. True or false? So now, it is after I've gotten derivative, we start doing the interpretation. So I extract. So now, in this extract dp, which I told you is your derivative, say okay. When you say okay, it's going to bring this to you. It's going to tell you that p at dt equals to 0 is this very value. I will show you where it got the value. It's telling you your last pressure point before you started the build up, before shorting. That is the value. Are you getting it? So you have to check and be sure that this is correct, because this is your PWF. Like those of you who are going to do Prosper, you will see that your PWF is that is your flowing bottom hole pressure before shorting. Very, very key. And it's the last pressure before you shorting. Did you understand? It's the last pressure before you shorten. So now it's giving us 2-1 this, and it's also estimating average pressure to be 4,072 something. Are you getting it? So this, I'll show you how this guy changes. Let's say okay now. If you say okay, all your derivative you were plotting with Excel has appeared. Can we see our plot?
Yes, ma'am.
So this is where interpretation sets in. So the green is your log plot, while the red is your derivative, like you saw in your material. You can expand any of them. You can use this fan tool, this hand, to move it up and down. So for all you did in class, can you tell me what kind of formation is this? Interpretation has started. Eh? Yes, use the derivative and tell me what kind of formation, because we want to interpret it. But I'm sure that Prince told us that in Niger Delta we don't have dual porosity, abi. So if I give you a job and you interpret it for me as dual porosity, I will just throw away your this thing because it's not correct. But you can see the dip, which makes you say dual porosity. So in place of the dip, there are other things, there are other heterogeneity that can cause this thing. When you have two layers that have two different formation properties, like two different K1 and K2, we saw it in that it will give you this dip. So you have that interconnectivity and then you have that's your omega. You have lambda and you have omega, and I'm sure Prince told you about it. So those are the two things that we need to match this late phase. But looking at this hump, what does the hump tell you? There is no way Prince will teach. I will not tell you that the hump, yeah, it gives you idea of the skin, it gives you idea of well bust storage. But if it's a well without skin, you will not see this hump. It will be almost flat. I'm sure he showed you that. So seeing this, you can interpret with paper, with your eye. I have seen heterogeneity here, Abi. I have seen skin, and so I'm expecting a value of skin. I've seen a high value of K, because the separation of this to this gives you information about. I've seen a flat, even if it's small. Are you seeing the flat? This distortion tells you that there was something that happened when this build-up was taking place that caused this a little bit, is it distortion or something like that. But finally, I can trace that this thing went flat again. So I can't see boundary here. I can't see any late time effect. So I can interpret it that it's still infinite acting. But in this reservoir, it makes a region of two layers, which I must match. So now, the interpretation is where all the things you have done from Monday till yesterday comes to play. The knowledge of what you did in class, this is where you're going to apply it. If you don't apply it, well, you'll be estimating wrongly for your well and your reservoir. So to apply it, we go to the model. At 5 minutes to go, you go to model. So from here, can we say that this is a steady well-bore storage? How do you know steady well-bore storage? Is when you can fit in this your set square 45 degree. Can you see it very well? And the line fits in very well. So there is strong well-bore storage here. Abi? Good. So constant well-bore storage. If you open it, you see all this other, this is asking, is it changing? Is it Hegman? All this changing and Hegman, most times when you have a well with very high GR and unstable. So our well is vertical. GOR, that is gas, high gas well or gas wells. So look at this one. Our well is vertical, even if you don't have that information. But we cannot say that our reservoir is homogeneous because we have seen a dip. Two layers, not two porosities, but two layers. So follow me in the interpretation. I'm interpreting first. So we're going to use, we don't have, where is it? You're saying two layers. So once I put two layers, it brings me omega and lambda so that I can use it to match. I have seen, I don't have boundary. I can't see fault because even after it dipped, it came back to flat. So it's infinite. So I've interpreted, this is the interpretation now that we're going to wear one trouser with. We keep refining to get a match. So you can check schematic of what you have interpreted. See what you've interpreted. Are you seeing it? A two-layer system. One with maybe higher permeability than the other, not porosity. Are you getting it? Good, that's what we interpreted. And we interpreted that it's a vertical well. No boundary. We did not have any boundary this thing, effects. Is that okay? So we say okay. Let's generate. When you're done with this, this is your interpretation. You say what? Generate. It generates for you. This is now what Sapphire has generated, but does it look like our data? No, not yet. So we need to match it. This is where the work comes. So before we even start to match, let's allow Sapphire to use its own regression to match this well. So we click on improve. Eh? When you click on improve, you run. Everything is selected. We're improving on everything. Improve, run. When you run, it's trying to match, but it's still not matching. That means we have to tweak a lot of parameters now. So do improve. Do another improve again and run and see if it will be better. We have not seen anything better. So that means we need to be the ones to match our data. So to match, we need to match the skin. Skin is not matching. When skin matches, it will match this hump. Are you getting me? The hump is not matching yet. So I'm going to try some values of skin. I'm going to go back to model. Go back to model. When you go to model, the skin is showing you negative, but this cannot be true. Abi?
Yes, ma'am.
Because we know that our skin is showing that it has a high value. Yes, then. It doesn't matter. Just change with me. Let's try skin of 30. The first one, maybe try this one. Make this one 25. Let's see. Only skin is what I modified. I just click generate. Are you seeing where I took my skin to? So it's higher than what it should be. So I bring it down. You see where the work is? This one can keep you here till the next day. So I want to modify. I want to modify which one again? The skin. The skin I proposed was too high. Let me use 15 and 20 and see. So it's trial and error.
There is no specific values to use.
No, 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 until you get what matches your. This one is too high.
No, you use 1,000.
Wow, I thought it's 10. Where is the 1,000?
Skin 2, 1,000.
So it's coming down, but it's not there. It has to match this derivative.
Okay.
So I have it to 5. I have it again.
Okay. Model.
The modeling now. No. It's coming down. 2, 2. I'm just matching one parameter at a time. Okay. I've tried to bring it down. Maybe let me
So it's
improve
skin
and
2 that
see.
requires network.
Eh?
Skin 2.
It doesn't matter. So no. So the next thing we're going to do, I'm going to let me just key in some values and see where it will take us to. It's model I'm using. Oh. Trying some value. What is lambda? Open your material, you see what lambda is. Search for lambda and omega. I'll show you something now.
Is there a way we can get reference value for this interval boundary parameter?
Get what? Okay, sometimes the only thing you can do when this model doesn't match, you can try other this here. Let me try radial composite and see. Coming close. If I come to improve, I can select regression points. You can say, if somebody listening to me can say, oh, that means you're asking it to match everything. You can say, okay, and you run. Just check. You can see come. Who is that? You can as well off every other thing and leave the things you want to match. Like I want to match K and this omega. I can run only those ones and see.
Display. Let me show you the one on top.
Oh, I want to move this guy. You can use this guy to be able to get a value of your omega and this thing that can match your well. So what's this value? Omega is 0.006, Abi. This one is 1.7 e raised to power.
-7.
So I can just, I've seen it. I can go back to here. So 0.066. Okay, it's what you have there. I now ask you to generate and see. So, but if I sit on this thing, is a whole day. Oh, that's why I will keep it last. I keep looking for a match. I've not gotten a match. I'm not even close to the match. I'm not close to the match because it has to represent what I have word for word. So, but before I leave, while she will continue with the matching, I have the semi-log plots. People did semi-log in class. We used to interpret the semi-log and also interpret the honor plot. To get the honor, you come here and do new plot and get honor. It will ask you the total production time is this. So I don't know if you understand what all the time it took this well to flow, minus that cleanup time, the pretest. That is what gives you total producing time. So if you say okay, it will bring out a new plot for you. Because we're trying to model it to see, you can see it's not matched here, it's not matched here, it's not matched here. So we have a lot of work to do. Model now. If I enlarge this one, in the model I have the option to play around with my permeability and all that. But because the thickness is fit, another thing you have to know is this thickness. If it's not correct, it will give you a lot of issue. So then I have this guy for this very, hello,
Yes, ma'am.
I was trying to say I have this guy so I can try to get this match by imposing a value. See this value. What do I have? 0.02
205.
something.
205.
0.025.
Minus 8.
Okay, and 4.24. Yes, it's just there. See, if you go here, click on this plus. You want to modify lambda. I say it covers lambda and omega. Click on it. You can use the palm tool to just raise it up so that you can see. Your interest is here. But before you do this, it's better you toggle off every other thing. That's what I was going to do. It will give you that new value. So I can go here, improve. I can go to improve. And I'll ask it, remove everything. I just want to work on only lambda and omega. So it's not talking to this other part. I can now run the improvement. So you continue. I think that's the last thing for us. This whole thing we've done is all you need to be able to interpret a typical well test data.